Get my up for you.
Okay.
Get preparation assignment. Oh wait, no, it's in my email.
Was there anything you guys wanted to go over in the preparation assignments, or do you want to just go to the quizzes?
Not for lesson 4, but for lesson 5, I have a couple that I couldn't get through. So we can
Yeah.
Yeah, I think lesson 5 would be a good one to review.
I think we're all kind of confused on that.
Okay,
Yeah.
good. I'm not the only one.
Okay, so do we want to just go through the whole assignment or what?
Do
you guys
I'm
have
cool
specific questions?
For lesson 4, I'd say we just go for the quiz.
Yeah,
Okay.
I think we're good with that.
Okay, we'll start with the number 4 quiz then.
Okay, let me get to that. Oh, this is lesson 5. Oops.
Yeah, my computer's lagging a lot, so if I randomly just am out of it, just I'll try to get back on, but
okay.
So just don't go on without me if I'm not there.
We'll include you. It's good.
Yeah, we can keep you in Messenger or something. Try and keep you in the loop. Okay. We can just go question by question like usual. I can start with number 1. Are you guys ready?
Go for it.
Cool.
Okay. Information. Use the following information to answer the next three problems. Human blood can be classified into one of 4 basic types: O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. The blood types and proportions given in the table above define a probability distribution.
Would that be the likelihood that someone would have that blood type?
I think so. I think it's also just making sure that that like falls within the rules, the 3 rules that.
Oh, right.
And I think that would be true because it adds up to
1.
1. So
yeah.
I would say true.
Why would it be true though?
From what I understand, just because it follows the 3 rules of probability.
Yeah, because it has to be a number between 0 and 1.
All right.
And then all of the numbers have to add up to 1. And then if you subtract 1, or if you subtract the probability from 1, that will give you the probability that it won't occur. So.
It does. You're right. Okay. Okay.
Okay. So, question number 4. What is the probability that a randomly selected person in the United States has type O blood? Round to 2 decimals.
Type O blood. Probability. 0.45.
Yeah,
So
that's what I was thinking.
Yeah.
Is it that simple?
It seems too simple, but I would say yes.
It would just be over 1, right?
Yeah.
Okay.
Yeah.
Okay. Question 5. What is the probability that a randomly selected person will not have type O blood? So that's just going to be 1 minus 0.45, so 0.55.
Yeah.
Basically.
Okay. I really like this chapter. This one's pretty simple.
This one was awesome. It was so easy.
Good. And then we hit 5.
Yeah, seriously.
Okay, I can do the next one.
Okay.
Use the following information for the next two questions. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Question 6. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from a bladder cancer patient?
Okay.
So 1 out of 7.
7.
Yeah.
0.143.
Yeah, that's what I got too.
Yep. Okay. All right. Question 7. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There's little evidence that dogs can detect bladder cancer. So, strong
I would say
evidence.
strong, yeah.
2. When would it not be strong, though?
I was thinking the same thing when I was reading the chapter, because I was thinking it would need to be at least over 50%, but they
That's what I thought.
showed an example of like a 47% one, and they were like, this is really strong evidence. So I was kind of confused by that. But I'm
So-
not really sure.
I'm just going by
22
the
over 54? Should we
Yeah.
divide that, or
We can.
I don't know,
It's like 40%, so I would say that's
40,
still
41%?
yeah.
So what do you think?
I would say
I'm
that's
just going
still
by the
probably pretty
phrase.
strong.
The phrase when they said it's very unlikely that the dog would do this well by random chance.
Yeah.
So yeah, it's strong evidence.
I think it's
Yeah. That's probably what I would say.
Okay. I'll do the next one. So M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. I do not see the table, but if you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy?
Do you guys want me to screen share?
I actually see it this time.
Okay.
Let me see if I
But
can
for
refresh it real quick.
Julia,
Okay. It looks like Taylor also got kicked out.
yeah.
That's odd. I've been having this issue a lot, though. Like, it just doesn't load.
Oh really?
Yeah, it's weird. Let's see if I can get it to load. Here we go. Okay.
Perfect. Okay. The probability of a red candy. So that'd just be 0.13.
I hope so.
Okay. Red candy. Okay.
Oh, okay, so we have to figure out green now.
Oh, the green. But the green one is blotched out, though.
So we
Unless-
just have to subtract
add
all
the
other
the
ones
from one.
0.13 plus 0.14 plus 0.13 plus.
So I got 0.16.
Me too. What about you, Julia? What did you get?
Yeah, it's 0.16.
Okay.
That's it?
I think so.
Okay.
And then number 10, let's just subtract that from 1. So I got 0.84.
Same.
So far, so good.
Okay, I'll read this one. Information. Use the following information to answer the next 3 questions. The ACT scores of students admitted into a medium-sized public university in the western United States were taken from capex.com. The following summary of statistics were calculated. Half of the observations are less than or equal to what number?
Would that be the median?
Yeah,
I
I
was just
think
thinking.
so. So 24?
Mhm.
Okay. Based on the information in the table above, the top 25% of the students scored above what number?
So that's quartile
So-
1? Or
I think that's quartile 3 because it's the top 25%. So the like,
Oh, it's because it would be the 75th percentile.
percentile?
yeah. So that's
Oh.
27.
So when I ask for something like that, it means so the top would always be the third
Yeah.
quartile.
Yeah, especially since it's saying above the top the top 25% scored above or something like that. Above what number?
Oh.
Instead of like below what number.
Mhm.
So, question 13. Which of the following statements is not one of the 3 rules of probability? If the probability is high, then the probability is positive.
That's what I was thinking.
Okay. Sweet. That's it, right? For the
Wait.
first test.
But I don't have that as in. Oh wait, no, never mind. Sorry.
Sorry, guys.
You back? Do you want us to catch you up? What question were you on?
Can you hear me?
Yeah, just barely. Kind of. It's a little bit
Hold on.
choppy.
Did you guys submit it?
I did not yet.
Not yet. Just so we can catch Taylor up.
Okay. Okay.
Sorry, guys. I don't
You're,
know what's
No, it's
going
okay.
on.
you're totally fine.
It's all good.
Yeah. Okay. Looks like Taylor might have left again. So maybe let's submit it and then we can catch her up when she comes back because I think we can still view the quiz questions.
Yeah, it does. It does. So I'm going to submit it right now.
Okay.
Let's go for it.
Sweet. We're on a great streak, guys.
We are so good.
Rocking it.
We are good.
Nice.
Okay. What were the main questions you guys had from lesson 5?
Mine was on the last question, number 8, and F, like on 7F.
Yeah, I had a couple.
Okay.
Yeah, 7F and then 7E. A hard time with, and then 6C and D. That was it.
Okay. Let's start with 6 then.
Because it says if a student scores in the 10th percentile, what would be their corresponding Z-score be? So I took 10th as a decimal, so I put 0.10 as the data, and then I did that minus the mean divided by the standard deviation, and it was different number than the answer key.
Did you use that curve chart thing they have? What's it called? The apex
normal-
chart?
Yeah, the
Or whatever.
normal probability applet or something like that.
Applet, apex, no, applet,
Yeah, but
yeah.
But I thought that for the because this one I just needed the Z-score, so
Yeah, so
applet was for probability, wasn't it?
it is, but you can put the probability at the top and then it will show you the Z-scores at the bottom, or you can put in the Z-scores at the bottom and it will show you the probability at the top, so it works both ways.
Oh,
So
okay,
if you put
so what?
Yeah, 0.1 at the top, and it'll show you the Z-score.
Oh.
Applet, that's what it's called.
Oh, okay. Good to know.
Do you guys use the I also learned that from the tutorial. The tutorial goes over all the questions I figured out. So that was very helpful as well.
Okay.
I did not. Oh, holy cow.
I didn't have time to go through it. You're right.
Yeah, I just had to plug in my computer.
Yeah.
Fine. Okay. So did you figure that out on the app thing?
Yes. Yeah.
Okay, perfect. And then what is the quantitative GRE score for a student who scores in the 10th percentile? So for that one, what I did is I just kind of took that equation, the Z-score equals standard deviation, or the observation minus the mean over the standard deviation. And I took that score, the 10% Z-score, and then put that equal to that equation. And then you solve for the X. So you have the standard deviation and the, what's it called? Mean. Does that make sense?
No, sorry.
No worries.
The Z-score formula?
Yeah.
Yeah. So there's the first number, which is the data minus the mean, and then divided by the standard deviation. Where are you plugging in? Wait. So which number don't we have? The data?
We don't have the X.
We don't have the observation.
X. Okay. So we just plug it in and do it backwards. Gotcha.
Uh-huh.
Yep. Okay. So then on number 7, what questions were there?
For me it was E and F.
Okay.
Yeah, me too. That was F.
Okay. So for E, what I did is I just took the number on C and the number on D, and I subtracted those from each other, because the one on C is like if you were to have all of that, the curve, if you were to have all of that filled, and then E is like just the end of it. So if you subtract, or I don't know if it was E. D is the end of it. So if you subtract D from C, then you just get the part in between the two, if that makes sense. I can draw you a picture. Okay.
I think so. So in the applet, which part did you fill in as blue?
I filled in the 2 for part C. I filled in the 2 rightmost or leftmost parts. And then for part D, I just filled in the most left part, just a 1.
Oh, okay. So nothing from the right. I think that's what I was doing wrong then.
Does that make sense, Julia? Don't
The
very well.
for E?
I don't.
For E, yeah, that makes sense.
Okay. Then for F, it's kind of similar to that one on 6, D. You just take, you put like 0.75 into the applet because you're on the 3rd quartile.
Okay.
And then you just find the z-score from that. So
0.75.
So I got a z-score of 0.674.
I did not get that.
I might have done that wrong.
Okay, I am going to the applet, and I am going to put it in. So it's 0.75?
That's what I put for the area. And then I got a z-score of 0.674.
I didn't get that. I got 0.319.
Okay, sorry to backtrack, you guys, but I'm still on E.
Okay.
No, it's okay.
Okay. I put in the z-score 0.5, and you said that one was the one that it's the middle and the left?
Sorry. So you solved the 2,500 and got 0.5. Is that right?
Wait, crap. Oh, I'm subtracting C from D?
No, you're subtracting, well, yeah, you're subtracting C from D, but in order to do that, you have to solve for the z-score of each of them.
Right, so for 2,500, it was 1.1667.
Yeah.
And then for 1,500, it was negative 0.5.
Yeah. So for the 0.1667, then that's the one that you do. You just put that in for the z-score on the bottom, and then you highlight both of them if you want to get the score for D.
Oh
no, the score for C, sorry.
For C, okay, so so did you get 0.9522 for that one?
I got 0.8784.
What am I doing wrong?
Which z-score did you put the actually, let me try something. Yeah, so let me share my screen with you. I don't know if this will help.
Okay.
But so for mine, I have, can you see this probability applet thing?
No.
Okay, let me try again. Okay, now can you see it?
Okay, yeah.
So I just put in that that 1.667 right, or 1.1667 right there, and then I just highlight both of these, and then that gives me 0.8784.
I'm a doofus. I didn't put the 1 in. Good job. Okay. 0.1667. Okay. 0.8784.
Yeah.
Um,
And then what was the z-score you got for the second one?
0.5.
So then do the same thing with that, but only highlight this one. And then you should get 0.385. I mean, 0.3085.
Wait, how did you get the z-score for for what was it, letter, I can't remember, C? How did you do that? Because I did it differently.
So what I did is I did 2,500 minus 1,800 because that's the mean, and then just
Okay.
divided that by 600,
Uh-huh.
and then that's how I got 1.6667. And then
Okay.
for B, you would do everything above that line to get the score, or to get the area, and then for C, you would do everything below that line.
Okay. So how do you determine which side of the curve you're highlighting?
So it depends on what they're asking. So like if you look at B, they're asking for a speed that is over 2,500 meters per second. So you want everything that's going to be higher. So you're going to do above that line.
So like only the right side?
Yeah, only the right side.
Okay.
And then for C, they're asking for everything that's less than. So you do everything to the left side.
So for the applet, I put in 1.6667. What about for the negative part, though? What did you put?
So the negative part typically follows the positive part. So they're like equal.
Mm-hmm.
So
if you put it in either way, it doesn't matter.
Yeah.
But I got 0.9522 for the area, though.
0.9522, and you put 1.1666.
Oh, 1.166?
Yeah.
That's my problem too. I accidentally put 1.667. And it came up wrong.
Oh my gosh. Okay. Okay. All right. This makes more sense.
Okay.
I'm so dumb. Okay, I'm good.
Okay, and then do you get how to get E now? Just subtracting those two numbers?
Yes. Yeah. Go down E. Go to F now.
And then F. So on that same quartile, you can put 0.75 in for the area, and then that should give you the z-score.
Mm-hmm.
And then you solve it kind of like we did on number 6. Just putting that z-score equal to the equation.
So are you looking for the data again? Are you looking for X?
Yes, you are looking for X.
Oh, I see. So it's 0.674?
For the z-score? Or for...
Yeah, for the z-score.
I didn't actually... 1 second. 0.75. Yeah, that's what I got.
Divided by, so it would be X minus 1,800 over 600?
Yeah. So you just do 0.674 times 600
Right.
plus 1800 or whatever it was.
So 1800 times 0.674, and then that would be plus 1800. So 3013.2. Ooh, wait, what?
I
Wait,
got
what?
2204.4.
I did something wrong. Oh, I know what I did. I did 1800 times 0.674. Okay. 600. 0.674. Right. Then plus 18. Okay, I got it. All right.
Perfect. Okay, and then you said number 8 as well.
Yeah.
So this one was kind of confusing to me too, but I just kind of tried to follow the ones that had, like, that kind of followed that line
Okay.
to be able to identify it. So if they had really high outliers, like in plot A, there's that one that's like all the way to the right, all by itself. So that would make it not normal. Or plot B, there's a few that are kind of like outliers. So that would make it not normal as well. But then like C and D, they have a few outliers, but they're pretty close to the line. So they'd be normal. E has a few of those outliers as well.
Not
So that's how I thought, that's how I looked through it, but
Yeah, I just kind of eyeballed those.
yeah, me too. It's kind of hard because there's not like a set line like this is too far and this is close enough.
See,
Right.
that's they all for me. I'm just like that looks the same at the line with dots, and so
Yeah.
like
Yeah, it's
figure
kind of
that out.
subjective, which is hard.
Okay, and then plot E is not normal though.
Yeah, because it's got
Yeah,
those
just because
outliers.
all the way left.
Yeah.
Oh, I see. Okay, I see. Okay, these are good to know. All right,
You guys ready to try out the quiz?
I think
Let's
so.
do it.
Let's hope for another 100%.
Oh boy.
Okay. Lesson 5.
Quiz. So should we just like for the question that asks if we finish the what's it called, practice individual
Individual.
preparation assignment?
Mm-hmm.
If you didn't finish it, should you just and you finished it now? Should we just put true, or because we finished it together, or what?
Yeah,
I'm still saying true because I did, like,
I think
I
if you,
did
yeah,
everything
I
that I
think if you
could.
try
Like,
with it and then we discuss it, I think that's kind of part of the reason for these group meetings. So I think it's
Okay.
all right.
Okay. All right.
Okay. So question 3. The total area under a normal distribution curve must equal 1?
Yeah.
Question 4. Under certain circumstances, a normal distribution curve can drop below the x-axis. Oh, I don't remember.
No.
I want to say false.
Yeah, I think that's false. I wrote
I think it's
density
false.
curve always lies on or above the horizontal axis. So
I don't remember reading anything like that, but so
Okay.
Okay.
so false. Okay.
Yeah.
Number 5. A normal distribution curve is symmetric.
True.
True. Yeah.
Okay. Use the following image to answer the next two questions. Which of the following elements of the figure represents the z-score? Z?
Yeah. I'd say C.
Okay, 7. Which of the following elements of the figure represents the probability that the z-score will be greater than 1?
I would say B.
Yeah.
Okay. Question 8. According to the 68, 95, 99.7 rule, what percentage of the data from the bell-shaped distribution will be within one standard deviation of the mean? Write your answer as a percentage such as 42 rather than a proportion. So 68?
68.
Yeah, 60. 60% or just 68?
I think just 68.
Yeah.
Okay. Sorry about my dog.
Don't worry about it.
All right, question 9. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -1 and 1? Give your answer as decimal. Accurate to 3 decimal places.
Okay, so this one's kind of like that other one. So if you just put in 1 on the z-score at the bottom and you click the 2 leftmost ones and get that area, and then take away the middle one and subtract the area that's left from the first one, I think that should give you the right answer.
Okay, so 0.8413 minus 0.1587.
Yeah, that's what I got too.
0.6826.
Sweet, I got the same thing. What about you, Julia?
So wait, I got like so. I'm
Sorry.
Oh wait, to 3 decimal places it should be 683. Sorry. Okay.
Here, let me screen share with you for a second.
Yeah, I am totally like.
So
Okay, yeah.
we just put in the 1 for the z-score here,
Mm-hmm.
and then that gives you the area of this whole thing that's lower. So the question is asking for the area between -1 and 1. So that's looking for this area. So if we take this total area and then we subtract this area from it, then that'll give you that. Or I guess we could just click on the middle one. That's a lot easier.
Oh, just the middle one.
I should have thought of that before, but
That's funny.
0 points. Okay. So it would be 0.683.
yeah,
Yeah.
exactly.
Okay. All right, that makes sense.
Okay.
Okay. So same thing for 10, but -2 and 2.
Yeah.
Okay.
This time you don't have to do the subtraction. Just use them.
So
I got
0.955.
Yes.
Yeah. And same with 11, so 3.
I like these questions.
Yes.
This isn't quite as hard as the homework.
I hope the test
Love
is like
plugging.
this.
Yeah.
Gosh. Okay, so 0.997.
Yeah. I guess these are all like exactly what the 68, 95, 99 rule are. We probably should have recognized that because it's like 1, 2, and 3 deviations away.
You're right. You're right. Whoops. Oh, the teacher watches this video. Is like, we recognize that.
She's probably going to be really entertained. Okay, question
Oh.
1.
It's exact. It was just what you were thinking.
Oh my gosh.
That's crazy.
Alrighty.
Man, you were good. So
Okay.
the 68 rule thing.
The value matches the rule.
Yeah.
That was funny.
That was good.
Okay.
Alright.
I'll do this
Alright,
one.
I can read. You want to read? Okay.
Sure, I'll read it. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that a protein requirement will be normally distributed if the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight, and that's the formula. The population mean protein requirement for adults is 0.65 grams protein times kilograms. Yeah, that. And the population standard deviation is 0.07. So, what proportion of the population have a protein requirement that is less than 0.60?
Okay.
Okay, so
it's
0.60. It's that. Is it the z-score formula again?
I'm thinking. And then we use that for the
So, yeah, I think we do 0.60 minus 0.65 because that's the mean divided by 0.07. Then you get a z-score. Well, I got a z-score of negative
minus
0.71.
0.5.
Yeah, and then we plug that in.
Yes.
Divided by 0.07. Wait, what?
What did you get for the z-score?
0.07? I don't
Yeah,
know.
that's what I.
Okay, good.
0. Yeah, I got 0.71.
Yeah.
Oh, wait. Let me redo this. So 0.60 minus 0.65 divided by 0.07. Oh, here we go. So, yeah, is it negative?
Yeah.
Yeah.
Okay.
So then when you put that into the applet, you'll put it on the negative side.
A negative. And is the other z-score going to be 1?
The other z-score will be the positive 7.14, but it should just automatically change when you put the negative one in.
Oh, I see. So negative 0.714.
So then we plug that into the applet and just highlight the very left part, right?
Yeah.
It's less than 0.60. So I got 0.239 would be, right? 3 decimal points.
I got 23876, but I might have put in the wrong numbers.
So the area says 0.2389, but if we're rounding it to 3 decimal places.
What did you put in for your z-score?
0.71.
Okay. I put 714 and it gave me 0.2376.
I would put in 3 decimal places because that's what we were talking about.
Oh, right, yeah.
Yeah.
Good call. Okay, so 2376, so 238.
0.238.
Okay.
0.238. Okay.
Okay. A proportion of the population have a protein requirement that is more than 60%?
So we're subtracting, right?
Yeah, or you can just highlight the other two.
That too. So 0.7624 or
Yep.
0.762.
Yep.
That's what I got. Okay. What proportion of the population have a protein requirement that is less than 70 grams?
So
Okay. So 0.70. Divided by
Okay.
0.6.
for the z-score, did you get up just 0.714?
Me too.
No, but I probably did it wrong.
That's
So
what I
let me
got.
try it
But
one more time. You guys probably got it.
I-
so we don't
But it's
really
like
need
the
to change
exact same
anything.
as the last one, so I want to do that again too.
I'm not sure what I did wrong. So
Oh, I was doing the wrong number. Sorry. I was doing minus 0.6 instead of 6.5.
let me see this. So it's 0.70 minus 0.65. Yeah, it's just positive.
Yeah, because it's the same distance away from the last one, from the mean as the last one was, just the positive way. So that
Okay.
makes sense.
All right. So then less than 0.7.
So then it would be 0.7624, the proportion, or 0.76, I guess.
That's less than 70?
62.
Less than,
That's what I got.
less than 0.70. So yeah, okay. So 0.762.
So I think that's the same answer as the last one.
Yeah.
Sweet.
Okay.
Okay.
Almost done. All right.
You find the probability that a randomly selected person will have a protein requirement that is between 60 and 70 grams. Reminder that you find the area between these two values. Shade the left of each z-score. So we could just click on the middle one, right? Because they're the same.
I think so.
You're on 16, right?
Yeah.
Yes. So then it would be 0.525.
I guess so.
Yeah.
Okay, two more.
Okay, so where do we put 0.35 in the area?
Yeah. And you want to make sure that you have like the middle one and the left one highlighted when you do it, just so that it makes sure to choose the right portion.
Wait, what? Can you tell me why we have the left two proportions highlighted?
Just because then it takes the area of those left two, or like it shows that you're looking for the smaller amount rather than the larger amount. Like you're looking for the bottom 35%, not the top 35.
Gotcha.
I don't know if
Okay.
it really changes it, but that's what it said to do on the instruction. So
Gotcha. Okay, so 0.675.
oh sorry, when you're doing like the actual z-score, you
Wait.
okay, sorry, you're looking at the z-score for the number that you need so that you can find the position.
So 0.454.
There we go.
You guys got 0.454 for the z-score?
Yeah.
Okay, I think I did something wrong.
Then what do you do after that?
Then you take that z-score and you put that equal to the equation for the z-score, so you can solve for
the missed for software X?
Yeah.
Okay.
Really quick, how did you guys get that z-score? Because I'm getting something different, but I don't know why.
I put in 0.35 at the top.
For the area?
Uh-huh.
Okay, now I have a different one.
I'm getting 0.385 or 3.
Yeah, so am I.
That's odd. Let me try again. 0.35?
Yep.
See, I'm just getting 0.454.
Do you have the middle and the left highlighted?
Middle and the left highlighted. No. So it's 0.675.
Yeah, so just click on those two when you're typing in the area, and then you can type it in and it will typically just highlight the leftmost one, but it just helps it to even out the z-score.
Oh, so it's 0.385.
Yeah, that's what I got.
How did you, why do you have to highlight that though? That was...
I don't really know. That's just what I remember reading on the reading part of it.
So is that just in general when you're doing it?
Yeah, that's typically what I do.
Did it say it depended on which percentage you're looking at?
Yeah, so like if you're looking for the top 35%, then you'll click on the right, like the middle and the right. But if you're looking for the bottom 35%, then you'll click on the middle and the left.
All right.
So the 35 percentile is going to be the middle and the left.
Yeah.
And then the top would be the middle and the right.
Yeah.
Okay. Okay.
So
okay.
Okay, so and then we plug it in.
So it's 0.35 times what? Are we going back to the other questions for like?
Yeah. So you're going to use that negative 0.385. And then you're going to multiply that by the standard deviation, which is 0.07.
Yep.
And then you're going to add the mean.
Negative. So it's going to be negative 0.385 times what?
Times 0.07. That the standard.
Oh, those. Okay.
Yeah.
0.7 plus 0.65.
Yeah.
Okay. You get 0.623.
Yes. Perfect.
So 0.623.
Yep.
Yeah.
Okay. Find the 80th percentile of the protein.
So we're doing the same thing?
Yeah.
Yep.
So we click on the middle and the left, and then we do the 0.8.
Yeah. You use the positive one.
Okay. So
now, why do we use the positive one, though?
Because you're using 80%. So, like, if you look at your chart, then it's highlighting up to that second line, which is where the positive one is.
And then why did we do the negative for the other one then?
Because it was only 30%. So you're going to be using less than half of that chart. So it's going to fall to that negative z-score.
Okay. 0.842, right?
Yeah, that's what I got to.
Times. plus 0.65. I got 0.709. Well, that's what I rounded to.
Not the same thing.
Same here.
Let's
All
do
right,
it.
that's good.
So should we just turn it in?
Yeah,
All right.
I just turned it in 100% again, guys. We're on a roll.
What?
Nice.
We are good.
Killing it.
And we're done for the week. Just gotta do
So
homework.
That is so nice.
Yeah,
guys.
seriously.
This is the
We got a
best
good thing going.
idea
Oh,
we've done.
Like it's a little bit extra work and like to start on a Monday because usually I don't have anything to do, but
Yeah,
No, it's worth it.
so worth it.
No, worth it.
Sweet. Well, we will see you guys next week.
Yeah. So are you going to
Yeah.
post this for both lessons then?
Sounds good.
Yeah, so I talked to the teacher and she just said post the same link for both. So I'll just post them both tonight.
Sweet.
Sweet.
Okay, cool.
All right. Thanks,
Yeah.
guys.
See ya.
Bye.